From Hartley 2, we blast off to the extreme outer edge of our solar system. A vast, eerie place, barely within the gravitational grasp of our sun, and impossible to see even with modern telescopes. Here, we come upon the largest and perhaps most elusive icy bodies in our galactic neighborhood. Our journey through the fascinating world of comets has provided us a ringside seat to some of the greatest cosmic shows observed from Earth and space. We now change course and travel over 50,000 times the distance between Earth and the Sun to the outermost edge of our solar system. We arrive at the Oort Cloud, an even larger fraternity of comets, perhaps over 1 trillion of them.
If we'd actually gotten a spaceship and tried to go out and, say, visit the Oort Cloud, this would have been a long journey. There's billions and billions of these objects, but there's a lot of space in between them.
Like the Kuiper Belt and scattered disk, the Oort Cloud objects may have formed closer to the Sun. But about 800 million years after the solar system was formed, the gravitational influence of the gas giant planets flung these comets out to the frigid edge of our solar system.
Some of these objects were flung into very highly elliptical orbits out into the Oort Cloud. Passing stars could circularize those orbits, making somewhat stable orbits for them.
Most of the Oort Cloud bodies have been in frozen hibernation since the birth of our solar system. They only become long-period comets when they get sucked into orbits that carry them inward towards the planets and the Sun. Scientists have never actually captured an image of the Oort Cloud, but they have good reason to believe it's there.
Even though scientists can't directly observe the Oort Cloud because it's so far away and so faint, what they are able to do is infer its existence because we can look at where all these long-period comets come from on the sky, and they seem to come from all different directions. There doesn't really seem to be a preferred direction for them. This suggests that the Oort Cloud, if it exists, is probably roughly spherical.
One of the big mysteries is what knocks these icy bodies off course and sends them cruising by our neighborhood of Earth.
The comets in the Oort Cloud are very susceptible to gravitational pulls from other things outside the solar system. One thing is passing stars. If a star happens to come close to our sun, it can scatter comets from the outer Oort Cloud.
Icy objects in the Oort Cloud can also be dislodged by gravitational perturbations that occur when the solar system goes through the plane of our galaxy. So the solar system is basically orbiting around the center of our galaxy, but it's also oscillating up and down. And when it goes through the plane, then gravitational interactions can perturb objects from the Oort Cloud into the inner solar system.
Some long-period comets take up to about 30 million years to complete one round trip around the Sun. Our spacecraft tracks a long-period comet for hundreds of thousands of miles until we approach planet Earth. As its icy tails unfurl, a layer of dust and ice zips through our planet's thin atmosphere, leaving visible trails known as a meteor shower.
I like to think of comets as sort of the pig pens of the solar system because as they orbit around the Sun, they leave a big messy trail of debris. But sometimes the Earth's orbit can intersect some of these dust bands, and when it does, we can sometimes see meteor showers. And those beautiful bright streaks of light that you see coming through the night sky are actually produced by particles that are most often no bigger than a sand grain.